In this lesson, you will learn how to divide polynomials using long division. We start by setting up the problem for long division. The polynomial on top, which is the dividend, goes inside the division symbol. The polynomial on the bottom, which is the divisor, goes in front. We will write the quotient above the division symbol. The first step is to divide the first term of the dividend by the first term of the divisor. X squared divided by x gives us x, right? We write this x on top, lining it up with the corresponding like term in the dividend. Next, we multiply this x by x plus 3. This is the same as distributing x to each term. So x times x gives us x squared, and x times 3 gives us 3x. We line up each term of the result with the corresponding like term in the dividend. Next, we subtract x squared plus 3x from x squared plus 7x. So, x squared minus x squared equals 0. They cancel out. And 7x minus 3x gives us 4x. Then, we bring down the next term, which is plus 12. Now, we repeat the three steps. First, we divide. Then we multiply. And finally, we subtract. So first, we divide 4x by x, which is going to give us 4. Write plus 4 on top. Then, we multiply 4 by x plus 3. 4 times x is 4x, and 4 times 3 is 12, right? Now, we subtract. 4x minus 4x equals 0. They cancel out. By the way, the first terms must always cancel out when you subtract. If they don't, you made a mistake when you divided or multiplied. So, you need to go back and check the previous steps. 12 minus 12 is 0, which means our remainder is 0. Therefore, the quotient is x plus 4, which is the answer for this division. To check if our answer is correct, we multiply it by the divisor. If it is correct, we should get the dividend. Let's FOIL this. X times x is x squared. X times 3 is 3x. 4 times x is 4x. 4 times 3 is 12. Then, combine like terms. This matches the dividend, so our answer is correct. In the next example, the remainder is not 0. How should we write our answer in such a case? This is important, so stay with me. Start by setting up the problem for long division. The polynomial on top goes inside the division symbol. The polynomial on the bottom goes in front. Before you start dividing, always make sure that the polynomials are written in standard form, which is in descending order of degrees. In this example, both the dividend and the divisor are written in standard form, so we can proceed with the division. First, divide 6x cubed by 2x. 6 divided by 2 is 3. X cubed divided by x is x squared, right? Write 3x squared on top. Next, multiply. 3x squared times 2x gives us 6x cubed. 3x squared times negative 1 is negative 3x squared. Next, subtract. The first terms cancel out, right? Negative 13x squared minus negative 3x squared gives us negative 10x squared, right? Then, bring down the next term. Now, repeat the three steps until the degree of the remainder is less than the divisor. Divide negative 10x squared by 2x. Negative 10 divided by 2 is negative 5. X squared divided by x is x. Write negative 5x on top. Then, multiply. Negative 5x times 2x is negative 10x squared, and negative 5x times negative 1 is 5x. Now, subtract. The first terms cancel out. 11x minus 5x is 6x. Then bring down the next term and repeat the three steps. 6x divided by 2x is 3, right? Then, multiply. 3 times 2x is 6x. 3 times negative 1 is negative 3. Now, subtract. The first terms cancel out. Negative 7 minus negative 3 gives us negative 4, which is the remainder. We stop the division when the degree of the remainder polynomial is less than the degree of the divisor. In this case, the degree of the remainder is 0, and the divisor is 1. So, we should stop the division here. When we have a remainder, to write the final answer, we add here the remainder over the divisor. Therefore, This is the final answer. To check if your answer is correct, multiply it by the divisor, and you should get the dividend. By the way, if you are curious why we add here the remainder over the divisor, I will explain that at the end of the video. In the next example, the polynomials have missing terms. What should we do in such a case? Notice that the polynomial on top is missing the x squared term, and the polynomial on the bottom is missing the x term. In such cases, we add placeholders for the missing terms to avoid making mistakes in the division process. For the polynomial on top, we add 0x squared. For the polynomial on the bottom, we add 0x. This doesn't change the values of the polynomials. Now, follow the same steps as in the previous examples. Feel free to pause the video and give it a try. Divide 2x to the fourth by x squared. To divide the variable part, just subtract the exponents. Next, multiply. 2x squared times x squared gives us 2x to the fourth, right? 2x squared times 0x is 0x cubed, and 2x squared times 1 is 2x squared. Then, subtract. The first terms cancel out. 3x cubed minus 0x cubed is 3x cubed. 0x squared minus 2x squared is negative 2x squared, right? Then bring down the next term. Now, repeat the three steps until the degree of the remainder is less than the divisor. Divide 3x cubed by x squared, which is equal to 3x. Then, multiply. 3x times x squared gives us 3x cubed. 3x times 0x is 0x squared. And 3x times 1 is 3x. Now, subtract. The first terms cancel out, right? Negative 2x squared minus 0x squared is negative 2x squared. Negative 5x minus 3x is negative 8x. Then, bring down the next term and repeat the three steps. Negative 2x squared divided by x squared equals negative 2, right? Then, multiply. Negative 2 times x squared is negative 2x squared. Negative 2 times 0x is 0x. And negative 2 times 1 is negative 2. Now, subtract. The first terms cancel out. Negative 8x minus 0x is negative 8x. 2 minus negative 2 gives us 4, right? Notice that the degree of the remainder polynomial is less than the degree of the divisor, so we should stop the division here. To write the final answer, add the remainder over the divisor. Therefore, this is the answer. Let me explain briefly why we add here the remainder over the divisor. Let's say we want to divide 7 by 2. 2 goes into 7 3 times, leaving a remainder of 1, right? In this division, 7 is the dividend, 2 is the divisor, 3 is the quotient, and 1 is the remainder. We know that the dividend equals the divisor times the quotient plus the remainder, right? Now, if we divide both sides by the divisor, we find that the dividend divided by the divisor equals the quotient plus the remainder over the divisor. This is exactly how we wrote our answer for second and third examples. If the remainder is 0, the dividend divided by the divisor would be just equal to the quotient, as in the first example. Thanks for watching. If you found this video helpful, please give it a thumbs up and consider subscribing.